Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over problems involving half-life. So the key to half-life problems is to figure out what the number of half-lives is that your sample has gone through, and then from there you can solve the problem. So that's by and large, not every single problem, but by and large you want to figure out, well, how many half-lives has this substance gone through? Now, after you figure out the number of half-lives, then depending on what the problem is asking, then you would multiply by two the number of half-lives, or you would divide by two according to the number of half-lives. And so that's the way you go. So if you're given the how do I say this? If you're given the amount that's left over and they want to know what's left, and you know the number of half lives, then you just work backwards. So here it's really important to understand what is the definition of half life. And a half life is the amount of time it takes for half of your sample to decay. So if you know that you're going through a certain number of half lives to get from one amount of the sample to the ending amount of your sample, then you would either multiply or divide by two, depending on which way you're going. So, for example, if I know that if I know that my sample went through five half lives, and I know the amount that I'm left with, and I want to know how much I started with, well, I got to work backwards. Since my original sample was halved each time to get to the amount I have now, then I know to go backwards, I have to multiply by two that same number of times. Same thing if I know the amount I'm starting with and I know I have five half-lives, then to find the ending amount or the amount that's left after five half-lives, then I'm going to divide the sample five times by two. Okay, so that's basically the gist of your half-life problem. So here we go. So for problem number A, or letter A, I should say, we're given that radon 222 has a half-life of 382 or 3.82 days. How long before the sample decreases to 1/32nd of the original amount? Okay, so looks complicated. It's like, how do we start this problem? I'm trying to find how long before the sample decreases to 1/32nd of the original amount. Well, what amount did we start with, right? We're not giving a beginning amount. So in this case, if this was a percentage, right? If we said, oh, how long would it take to get to 12.5%? Well, what you would do is you would start with 100%. Well, we always start with 100% of the sample, and then you go through the number of half-lives by taking 100% and dividing it by two each time till you get to that percentage, 12.5, right? So it's similar to the fraction. So instead of starting with 100%, right, how do you get to 100%? It's something divided by something. It's a whole, it's a part divided by a whole multiplied by 100 to get the percent. You always multiply by 100 to get a percentage. Well, if you divide by 100, you go back to the fraction. So what's 100% divided by 100? 1. So let's start with 1. So if we start with 1, and then we divide that by 2 each time, right? So if I take one half-life, I divide 1 by 2. So my sample is 1. Every half-life I'm going to divide by 2. So I divide by 2 here. So I'm going to divide by 2. What do I get? 1/2. If I divide that by 2 again, what do I get? 1/4. And I keep doing that until I get to 1/32. So let's go ahead. So if I divide this by a half, then I get 1/8, or 1/16. And then I divide that by a half again, or divided by 2, I should say, divided by 2 again, and I get 1/32. So how many times did I have to divide by 2? 1, 2, 3, 4. Let's make sure that's right. 1, 2, and 3. Oops, I forgot one. I knew I forgot one. So divided by 2, that's going to be 8, not 16. My bad. 8. I thought something was weird. And then 1/8 divided by 2 again, that's going to be 1/16. And then divided by 2 again, that's going to give me my 1/32. And so that looks right. Okay, so how many times is it divided by 2? I have 1, 2, 3, 4, 5. So I have 5 half-lives. Okay, so again, half-life is the amount of time it takes to undergo the process of decaying half of your substance. So they're asking, well, if the half-life is 3.82 days, how long will it take to get to 1/32? Well, I know it took 5 half-lives, and I know each half-life is 3.82 days. So I'm going to take the 3.82 days and multiply by 5 half-lives. So 3.82 days multiplied by 5. And what do I get for my answer? 19.1 days. So this is equal to 19.1 days. And that is how you solve this half-life problem. Okay, let's go to the next one. Oh, and by the way, again, if they said, if this was a percentage, let's say it was 12.5%, right? So radon, if they gave you radon 222 has a half-life of 3.82 days, how long before the sample decreases to 12.5%? I'll just throw out a number, 12.5% of the original sample. In this case, you do the exact same thing. Instead of starting with 1, though, you start with 100% because you always start with 100% of your sample. And then you keep dividing the 100% by 2. Divided by 2, you get 50. Divided by 2 again, you get 25. Divided by 2 again, you get 12.5. So 3 half-lives. Okay, so problem B. So hydrogen 3, also known as tritium, has a half-life of 12.26 years. How long before the sample decreases to 1/8 of its original amount? So we do the same thing. So we assume that our original amount is 1, right? Not 100%, but 1, because 100 divided by 100 is 1, right? So we got 1. So notice that there's a 1 up here too, so that's helpful. So we're taking 1, and we're going to divide it by 2 until we get an 8 on the bottom, right? So I take my 1, divided that by 2, and I get 1/2. If I take the 1/2 and divide it by 2 again, I get 1/4. And then take the 1/4 divided by 2 again, and I get 1/8. So now, well, how many half-lives did I have to go through? I went 1. How many times did I have to divide by 2? 1, 2, 3. So that's 3 half-lives I had to go through. So for each half-life, it takes 12.26 years. I went through 3 of them. So I'm going to take the 12.26 years multiplied by 3, and I get my answer. And let's see, the answer is 3678. So 36.78 years. So it takes that long for you to go through 3 half-lives. Okay, next, C. Here we have plutonium-239. We're told it has a half-life of 2.44 times 10 to the 4 years. That's a long half-life. So what fraction will be left after 9.76 times 10 to the 4 years? Okay, so here we want to know, well, what fraction is left? So in these two problems, we're given the fraction that is left, and then we were asked to find the total amount of time it would take to get to that fraction. Now we're given the time that it takes to undergo this particular decay, and we want to know, well, what fraction is left after that. Well, again, we need to figure out the number of half-lives. So we're given that the half-life is 2.44 times 10 to the 4 years, right? This is the total amount of time. It would be nice to figure out, well, how many of these half-lives can fit into that amount of time, right? So let's divide the half-life into the number of years, the total amount of time. So we'll take the total amount of time. I'll write this as an equation for those nerds out there. So time, T is the total amount of time, H is the half-life. T divided by H is going to be equal to the number of half-lives. Okay, so to find the number of half-lives, we're going to take the total number of years, 9.76 times 10 to the 4 years. We're going to divide that by the half-life, which is 2.44 times 10 to the 4 years. And when you divide that, I'm pretty sure you get 4 half-lives. Let me double check. Yes, you get 4 half-lives. So you divide that, you get 4 half-lives. And so now that we know we have 4 half-lives, all we need to do is to get the fraction is take 1 and divide it by 2 4 times. So we're starting with an amount of 1, and we're going to divide that by 2 4 times. So divided by 2 gives us 1/2. That's 1. Divided by 2 gives us 1/4. Divide that by 2 gives us 1/8. And that's 1, 2, 3. One more divided by 2, and that gives us 1/16. So 1/16 of our original sample would be left after 4 half-lives. Okay, next problem. Last but not least, we have uranium-238. Uranium-238 has a half-life of 4.51 times 10 to the 9 years. That's 4.51 billion years. What fraction of the sample is left after 9.02 times 10 to the 9 years? So again, to find the number of half-lives, right, we got to take the total time divided by the half-life. So the total time over the half-life, that's going to be equal to what's total time? 9.02 times 10 to the 9. So the total amount of time is 9.02 times 10 to the 9 years. We're going to take that total amount of time and divide it by the half-life. That's going to be 4.51 times 10 to the 9 years. And then we divide that and look, it's 2. We get 2. So we get the number 2. So that's 2 half-lives. So that means that whatever sample we start with, it's going to have the fraction's going to be after 2 half-lives. We're going to divide that by 2. So again, we start with 1 as our amount. So if we start with 1, we're going to divide that by 2, and we get 1/2, and then divide that by 2, and divide that by 2, and we get 1/4. So that means that after 2 half-lives, we'll have 1/4 of our sample left, whatever that sample is. And that's, ladies and gentlemen, is how you can solve these half-life problems. So I hope this was helpful. If this was helpful. If you enjoyed this video, then by all means, like the video, share the video, hit that notification bell. Also, when you do that, make sure that you click all so you have that you can be notified by all the videos I put out. And then finally, well, before I say that, please subscribe to my channel. Thank you very much. And put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to go over, or a topic you want me to cover, put that down below in the comment section. I would like to cover that for you. Thanks for joining me, and have a great day.